So today we are going to see one chapter from your pharmaceutical engineering. We have already seen few chapters from pharmaceutical engineering for one batch. For one batch, I have completed size reduction, size separation, drying, evaporation, then crystallization, distillation. And for them, it will be a new chapter. And from for new batch, again, it will be a first chapter from your pharmaceutical engineering. Basically, this pharmaceutical engineering is not easy subject. It is very hard to understand. It is not easy to understand because the concept, because the terminology, because the theory part, because the derivation of equation. So they belongs to some mathematical concepts, and they belongs to some engineering concepts. But what is important for us? So that is going to be discussed over here for your GPAT Niper DI Pharmacist. What are the important points from that chapter? What are the important points that you have to focus on? From which portion question has been asked already? So that will be discussed over here, right? So we are going to see flow of fluid. Flow of fluid again is very important chapter. Flow of fluid is important chapter, and you may expect two questions, maximum two questions from this chapter. Flow of fluid, okay, flow of fluid, then transportation of fluid is there, and after that mixing is there. So that we will see later on, but now we'll see the flow of fluid, the flow of fluid. Okay, so pharmaceutical engineering, flow of fluid, after that we will see transportation of fluid, and after that mixing and filtration. So size reduction, size separation, drying, evaporation, crystallization, and distillation. So these chapters are completed for batch one batch, and for your batch I'm going to take separately. Okay, don't worry. So first, what is meant by flow of fluid? Flow of fluid. So as I told you, this chapter is, again, you can say it is important, or you can say it is not much important, but most of the times only one or two questions, they are the probable question from this chapter. एक या दो क्वेश्चन प्रोबेबली यहाँ से उठाते हैं क्वेश्चन जीपैट में, ठीक है। तो कहाँ कहाँ से आ चुके हैं अपन देखेंगे. आई विल एक्सप्लेन यू दिस चैप्टर इन अ different way. Okay. Now, first, what do you mean by flow of fluid? So, flow means what? It is nothing but the movement. It is nothing but the movement. So, flow of fluid is nothing but the resistance to the viscosity. Flow of fluid is resistance to viscosity. So, flow and viscosity, they are the, okay, they are the inversely proportional, right? So flow of fluid, as per the standard definition, it is defined as the flow of substance that do not permanently resist the distortion, that permanent do not permanently resist the distortion. Flow of fluid is defined as the flow of substance that do not permanently resist the distortion. Okay? So that is the definition of flow of fluid. You have to remember. Now there are two kind of terms: fluid static and fluid dynamic. Static means at the rest, at the equilibrium. जब कोई fluid. So what do you mean by fluid itself? So you might know the state of matter. So there are solid state, there are liquid state, there is a gaseous state. Okay. So if two states are mixed, say for example solid and gas, अगर आपके पास में पाउडर का कोई एयर सस्पेंशन है, that is known as a fluid. So if liquid plus solid is there, so if it is totally soluble, it is known as a solution. Rest of the, it is known as a fluid again. Okay. If liquid or gas, air stream, okay, vapors plus air, again fluid. Okay, so it is a intermediate state, it is a mixture of two state of matter, either liquid or solid, uh, liquid or gas or solid. So mixture of two state of matter of, okay, two state of matter of the anything. So मैटर का कोई भी दो स्टेट होगा, उसका मिक्सचर होगा, तो बनेगा आपका फ्लूइड. सो फ्लूइड फ्लो मीन्स व्हाट? इट मे बी डिफाइंड एज अ फ्लो ऑफ सब्सटेंस दैट रेजिस्ट द, दैट डू नॉट परमानेंटली रेजिस्ट द डिस्टॉर्शन. तो एक स्टैंडर्ड डेफिनेशन. नाउ mass of fluid is considered as a, it is made up of different layers. So mass of fluid is considered as a made up of a different layers. Suppose you have this mass. Now, mass of fluid is considered as a composed of a different layers. यहाँ पे एक layer है, यहाँ पे एक layer है. So mass of fluid is composed of a different layers. When you apply some force over here, when you apply some force over here, when you apply some force over here in the form of either जैसे आप mixing करते हो, so you are mixing, you are using mixer grinder, you are stirring, आप कॉफी में चम्मच डाल के मिक्स करते हो, so you are applying some kind of force to mix up that, right? So if you apply a force on that fluid or okay, or mass of fluid, so what will happen? So they will slide, each and every layer will slide on each other, each and every layer will slide on, you will get a diagram like this, so कुछ इस तरीके से diagram, so every layer will slide on each other. So fluid mass is composed of a different layers. First of all you have to understand this. Okay, now fluid static means what? Fluid static means when fluid at rest, अगर fluid rest में है, movement नहीं हो रहा है, if there is no flow, so it is known as a fluid at rest. So fluid statics deals with the fluid at rest or fluid at equilibrium. Okay? Now fluid dynamic means what? Fluid dynamics means study of fluid in the motion, study of fluid in the motion. Now this, why you have to do study of fluid in the motion? Because there are a lot of unit operations in the pharmaceutical engineering, pharmaceutical industry. Uh, for example, bottling means bottling of syrup, means you have to fill the syrup. आपने कुछ syrup prepare किया है इंडस्ट्री में और उसको fill up करना है बॉटल में, तो प्रिपरेशन टैंक जो है, स्टोरेज टैंक जो है ना, आपका स्टोरेज वेसल जो है वो, और ठीक है, दूसरे रूम में, स्टोरेज टैंक्स और मैन्युफैक्चरिंग यूनिट और प्रोडक्शन टैंक इज ऑन another room, but packing line is on at another room. So you have to transport that syrup through a pipeline at the machine, at the packing machine. From that packing machine you have to fill that bottle. Okay, so during this whole operation, so the flow of fluid is very important. So what kind of flow is there, whether turbulent, whether viscous, so that will decide what type of equipment you have to use for the production. Okay, so remember, fluid static deals with the fluid at rest or in equilibrium, and fluid dynamic deals with the fluid in the motion, right? Now fluid is nothing but the mass of substance which are formed by a series of layers, as I have explained. When we try to make change in its shape, when you try to make any change in its shape by application of certain pressure or force, the layers of that mass will slide over one another until new shape is formed. Okay, until new shape is, the stress will be relieved on the flow. Okay, now the stress will be relieved from newly shaped formed fluid, and the fluid will change its position, means it will get some kind of motion. So stress will be relieved on the fluid and fluid flow will start. The fluid flow will affected, means if you apply a pressure, suppose you have this kind of mass, so you have this kind of mass, so fluid mass is made up of layers. If you apply some pressure over here in the form of stirring or in the form of something over, how it will flow? So it will change the shape, it will change the shape like this. So layer will be like this. So one layer will slide on another layer, one layer will slide on another layer, and after this, so whatever stress was applied, that will be relieved, and there is a beginning of flow of that fluid. Okay, so remember, fluid static means fluid at the rest, fluid dynamic means fluid in the motion. ठीक है, fluid static मतलब rest में होता है, fluid dynamic मतलब जब fluid movement में होता है. So this fluid dynamic is very important for our pharmaceutical industry. That's why you have to study this flow of fluid, otherwise there is no reason. Okay, because lot of operations, billing operation, like for example if you are carrying out any reaction, जैसे बल्क ड्रग इंडस्ट्री में होता है, इफ यू वांट टू कैरी आउट द रिएक्शन, ठीक है, सो यू वांट टू सिंथेसाइज सम कंपाउंड, एंड फॉर दैट यू नीड अ रिएक्टेंट, सम रिएक्टेंट आर लिक्विड इन नेचर, जैसे क्लोरोफॉर्म हो गया, अल्कोहल हो गया, वाटर हो गया, so you have to transport that water, chloroform or reactant to a reaction vessel. You have to charge that uh, charge that reactant to the reaction vessel. So during that charge, okay, the quantity of reactant to be added, that depends on the flow of fluid. Okay, so that's why you have to study this flow of fluid. Okay, so there are a lot of applications of flow of fluid in industry. So flow of fluid is seen in. So where you require this flow of fluid, or where you observe the flow of fluid in the industry, right? So flow of fluid is seen in case of handling of liquid. For example, during the transportation of solution and suspension, handling of solid. Handling of solid is troublesome in the industry, but handling of liquid is little bit easy. Second, handling of solid or handling solids are handled in the form of finely divided particles which are suspended in the air and then it is transported. Okay, that is known as a fluidized state. So powder particles in the air known as a fluidized state. So it is one of the state of matter. State of matter is now the solid, liquid, and air. Okay, solid, liquid, and gas. Solid, liquid, gas. These are the state of matter. Solid, liquid, gas. But solid, liquid mixture normally we call it solution or suspension or emulsion. But it is a fluid in nature. Two mixture of two state. Then again, solid plus gas known as a fluid. Liquid and gas again fluid. So mixture of two state of matter, it is known as a fluid. Fluid is a mixture of two state of matter, right? Now flow of fluid is seen in the various unit operations in the industry, like handling of liquids during transportation, then during transportation of solution suspension in the packing unit. यहाँ पे आपने एक रिएक्शन, आपका जो मैन्युफैक्चरिंग वेसल है, स्टोरेज टैंक है, वहां से आपने उसको सिंथेसाइज, उसको फॉर्मुलेट किया एज पर द फॉर्मूला, सॉल्यूशन बना दिया, सिरप बना दिया, बट फॉर द पैकिंग पर्पज यू हैव टू ट्रांसपोर्ट दैट syrup to the packing unit, and during that you have to select the equipment, and the equipment for transportation like pipe, valve. Okay, so that will be decided by the type of flow, of that fluid. So that's why you have to understand this flow of fluid in the pharmaceutical industry, right? So solids are handled in the form of fluidized state in the air. Okay, now, behavior of liquid changes in a handling process, and that has an impact on the either heat transfer, energy losses during pumping, energy change during pumping, and okay. So fluid behavior, जैसे fluid static है, so static मतलब if fluid is on a rest, so at that time it has a different behavior. When fluid is in a motion, when fluid is in a dynamic condition, so at that time it has a different characteristic of behavior. So the behavior of liquid changes in the handling process, which have impact on heat transfer. For example, suppose you are doing evaporation. For that you are using steam, water with air, steam. Okay, so if the flow is turbulent, so heat loss is maximum. If flow is uniform, heat loss is minimum. So okay, so that's why behavior of liquid will change in a handling process, so which will have impact on the heat transfer, energy loss during pumping, energy changes during pumping, and okay, fluid flow is involved in fluid flow कहाँ पे होता है आपका, so it is involved in the different process. So examples of some process: charging of reactants. So when suppose you are carrying out one reaction in the bulk drug industry, जैसे पैरासिटामोल सिंथेसिस करना है आपको, उसके लिए क्या क्या लगेगा, उसके लिए रिएक्टेंट लगेगा, उसके लिए कोई क्लोरीन गैस लगेगा, उसके लिए या फिर कोई अमोनिया लगेगा. सो चार्जिंग ऑफ रिएक्टेंट into the reaction tank, so at that time, and you know that for the reaction you need a precise amount. ठीक है, कितना मोल है, मोल के ऊपर डिपेंड है, कितना मोल कितना रिएक्ट करना है, so you need a particular quantity. Okay, and you have to control the quantity during the reaction. So for that you need to control the flow, and for to control the flow you need to understand what is meant by fluid flow, what are the types of flow. Okay? Then transfer of air in a broth, transfer of air in a nutrient broth during fermentation. Fermentation process में भी क्या है, transfer of air in the nutrient broth. So at that time also fluid flow is observed. Filling of liquid bolus into containers. So filling of liquid bolus into containers, like solution in the bottle, suspension in the bottle, like that. Then transfer of sterile air, AIR है, air हो गया, AIR. Transfer of sterile air and sterile water into the parenteral area. So at that time also flow of fluid is involved. Mixing of solid and liquid or suspension. So at that time also flow of fluid is involved. Okay. So for mixing also flow of fluid is important. During the packing of semi-solid preparation like ointments, creams. Okay. At that time also flow of fluid is involved. So these are the areas where you will encounter the fluid flow, right? Now the type of flow, okay, the type of flow of fluid, whether it is a turbulent flow, whether it is a viscous flow, whether it is a streamline flow, so that affect the type of equipment to be used. कौन सा equipment use करना है वो उसके ऊपर डिपेंड है कि कौन सा flow है. Okay? So type of fluid flow will affect the equipment used in the process. Okay, and that's why measurement of flow is important for the quantification of reactant in the process. कि आपने कितना क्वांटिटी का रिएक्टेंट डालना है. क्लोरीन गैस का आपको रिएक्शन करना है. ओके, सपोज एक इंटरमीडिएट है, उसको क्लोरीन गैस के साथ में आपको रिएक्शन करना है और बाद में आपको प्रोडक्ट मिलने वाला है, राइट. सो हाउ मच क्वांटिटी ऑफ क्लोरीन गैस शुड बी charged, should be sent to that reaction vessel. So that depends on the flow. Okay, and that's why the measurement of flow is important. And for the measurement of flow, you should know the flow characteristic of that fluid. Okay, now you can see over here. So suppose this is a glass vessel. This is a glass vessel, and this is a glass vessel. Okay, and if you at this point, if you break this at this point also and at this point also, there are two different points from which liquid is coming outside. The force at which the fluid will flow at this point will be different, and the force at which fluid will flow from this point will be different. दोनों पॉइंट्स में जो प्रेशर डिफरेंस है ना, वो प्रेशर डिफरेंस आएगा. ओके, बिकॉज ओके देयर इज अ रीजन व्हाई. Okay, say consider this is a point 1. Okay, point 1. So the flow of this liquid from point 1 will be different, and flow of liquid at this point, point number 2, this will be different, because these two points, they are at a different heights, and flow property changes with the height. So you can see over here. So consider a atmospheric pressure. Okay, at the point 1. So this is the pressure at a point 1. point 1 के यहाँ पे इतना प्रेशर है. now at okay two vessels, ये यहाँ पे जो है ना, it is a continuously constantly प्रेशर इसमें इंट्रोड्यूस किया. मतलब यहाँ पे आपको वाटर, जैसे वाटर है तो वाटर यहाँ पे इनलेट किया जाता है कांस्टेंट एट अ कांस्टेंट प्रेशर. at a constant pressure water is passed from this point. Okay, the flow from point 1 and point 2 will be different because of the difference in the pressure which is experienced by the liquid at each point. तो ये जो point पे है point 1, at this point pressure will be different. This fluid will experience different pressure. At this point fluid will experience different pressure. Suppose a pressure acting on a surface of liquid is a PS, and at point 1, what will be the type of flow? That will be decided by height. So difference in the height will decide the difference in the flow. So hydrostatic pressure observed at a different layer in a stationary column, different hydrostatic pressure will be observed. Okay, so the pressure experienced by the liquid at the point 1, pressure experienced by the liquid at the point 1 will be different, and pressure experienced at the point 2 will be different. जैसे ये point 2 है और ये क्या है, and that's why at point 1 and point 2 they will experience a different pressure, and that's why they will have a different flow. Okay, so hydrostatic pressure difference at the different level, that depends on the height and pressure on which pressure exerted by the air at that surface. So this is known as a condition where there is a static. It is known as fluid statics. So fluid static. Okay, so pressure difference between different layers of liquid. So at a point 1 there was a different pressure was experiencing. So point 1 में liquid जो है वो different pressure experience कर रहा था. Okay, 0.2 के ऊपर डिफरेंट प्रेशर एक्सपीरियंस कर रहा था, 0.2 के ऊपर ज़्यादा प्रेशर एक्सपीरियंस कर रहा था, ज़्यादा प्रेशर तो ज़्यादा फ्लो आ रहा था 0.2 के यहाँ से, 0.1 के वहाँ से बहुत ही कम फ्लो आ रहा था, बिकॉज प्रेशर कम आ रहा था वहाँ पे, क्योंकि कम प्रेशर एक्सपीरियंस करते हैं। So the flow of liquid through two different opening or two different holes at a different height. जैसे अबोव डायग्राम में देखा, एक ज़्यादा हाइट पे था, एक कम हाइट पे था, जो ओपनिंग था from that column, from that vessel. The flow of liquid through two different opening at different height will be different. The flow will be different because of the pressure exerted will be different at a different height. Pressure exerted by atmosphere on a liquid, that will be different at a different height, and that's why there will be difference in the flow. Right? Now the force is nothing but the pressure. The force or pressure acting on a liquid at a different point. It can be calculated if the cross section area, if the cross section of that column is constant or uniform from the top to bottom. The forces acting on each side. Forces acting on each side. मतलब forces acting on this, जैसे मान लीजिए अगर आपने ये पॉइंट कंसिडर किया यहाँ पे, the forces acting on this side and forces acting on this side, they will be nullified. They will be nullified. So only force acting on this from the, okay, so that will be taken into consideration. Okay, the force or pressure acting on a different points can be calculated. So पहले पॉइंट की ऊपर कितना फोर्स अप्लाई हो रहा है, प्रेशर कितना है, सेकंड पॉइंट के ऊपर कितना प्रेशर है, that can be calculated if the column has a uniform cross section. The forces acting on each side at a point 1 are mutually nullified because horizontally pressure same रहेगा, so that is nullified. The forces, okay, forces at a point 1 exactly point 1 के ऊपर मतलब 1 पे forces जो है left side पे right side पे, that will be nullified because they will have some, but only forces above the point 1 के ऊपर कितना फोर्स है, point 2 के ऊपर कितना फोर्स है, exactly point 1 में कितना फोर्स है वो नहीं कैलकुलेट because that is nullified because of the forces, okay? Because of the forces above, okay, only forces which are above the point 1 or above the point 2 that can be calculated, okay? That can be calculated. Now force at a point 1 is nothing but the force at a point 1. How to calculate force at a point 1 will be surface force means pressure and force exerted by liquid above the point 1. So force or pressure at a point 1 कैसे कैलकुलेट करेंगे, फोर्स सरफेस फोर्स इनटू फोर्स एक्सर्टेड बाय लिक्विड अबव द पॉइंट, उसको ऐसे भी लिख सकते हैं एज प्रेशर इज इक्वल टू, प्रेशर का फॉर्मूला होता है क्रॉस सेक्शनल एरिया, ओके, प्रेशर, ओके, ये मतलब फोर्स, एज फोर्स इज इक्वल टू प्रेशर इनटू क्रॉस सेक्शनल एरिया. तो फोर्स एट अ पॉइंट 1 विल बी रिटन इन द डिफरेंट वे, लाइक सब्स्टिट्यूटिंग द फोर्स टर्म, फोर्स जो टर्म है उसको सब्स्टिट्यूट करेंगे अपन प्रेशर इनटू क्रॉस सेक्शनल एरिया, ठीक है. सो ऐसा आएगा प्रेशर एट अ पॉइंट 1, प्रेशर एट अ पॉइंट 1 इज इक्वल टू, pressure at a point 1 is equal to surface area, okay, pressure at a point 1 into its surface area. So if you replace a force term, अगर आपने ये force term replace किया किससे, force is equal to pressure into cross sectional area, ये दोनों आएगा, force की जगह ये दोनों आएगा, ठीक है. So force at point 1 मतलब pressure into cross sectional area at point 1, ठीक है, pressure into cross sectional, pressure into surface area okay at point 1 is equal to क्या है, is equal to pressure surface force into force exerted by liquid at liquid at a point 1 above point 1. So इसका pressure at a point 1 into surface area is equal to pressure on the surface into surface area divided by mass into acceleration plus mass into acceleration. तो ऐसा आएगा, ठीक है इसका. So now I will explain this with the help of book. इसका आगे का पार्ट जो है बुक में है डेरिवेशन. सो प्रेशर एट पॉइंट 1 फोर्स एक्टिंग ऑन अ पॉइंट 1 इज इक्वल टू फोर्स ऑन द सरफेस प्लस फोर्स एक्सर्टेड बाय लिक्विड अबव एट पॉइंट 1. तो उसमें फोर्स क्या होता है, फोर्स इज इक्वल टू आपका प्रेशर एंड क्रॉस सेक्शनल एरिया. फोर्स इज इक्वल टू प्रेशर इनटू क्रॉस सेक्शनल एरिया. So put that cross section area into force into pressure is equal to force. Force term की जगह ये डाल दो, कौन सा ये term क्या आएगा? So pressure at a point 1 into surface area, so is equal to pressure on the surface into surface area plus mass into acceleration. तो प्रेशर को P बोलो, ये क्रॉस सेक्शन एरिया को S बोलो. P1 S1 is equal to PS मतलब प्रेशर एट अ सरफेस इनटू एरिया प्लस, ठीक है, प्लस ये प्लस में क्या है यहाँ पे मास इनटू एक्सेलरेशन. मास इज इक्वल टू क्या है? मास इज इक्वल टू वॉल्यूम इनटू डेंसिटी, क्योंकि मास तो यहाँ पे सॉलिड थोड़ी, ये तो फ्लूइड है. फ्लूइड मतलब लिक्विड रहेगा या फ्लूइड, मोस्टली ये लिक्विड ही रहता है, ठीक है, इसमें आप ये चैप्टर में, ठीक है. सो फॉर दैट you know density is equal to mass upon volume, so mass is equal to volume into density and then accelerated to gravity. So okay, so p1 is equal to ps means surface pressure into cross sectional area plus volume into density into acceleration due to gravity. So is equal to ये टर्म सेम, वॉल्यूम जो है, वॉल्यूम क्या होता है? height into area volume, then density as it is, and then acceleration to gravity. So we will get derivation like this. Okay, lastly at the point 1, okay, you have to calculate the same thing. Point 1 के जैसे pressure आपने ये calculate है, so this will the pressure at a point 1. P1 S is equal to PS into S H1 S into rho G. rho क्या है? डेंसिटी. ये g क्या है? एक्सेलरेशन ड्यू टू ग्रेविटी. रो डेंसिटी है, g एक्सेलरेशन ड्यू टू ग्रेविटी. दिस इज द प्रेशर व्हिच इज फेल्ट बाय लिक्विड एट अ पॉइंट 1, ठीक है. अब ऐसे ही आपको पॉइंट 2 जो है उसके लिए कैलकुलेट करना है, वैसे ही. सो ये आएगा उसके लिए इक्वेशन. नाउ डिफरेंस इन द प्रेशर डिफरेंशियल P2 माइनस P1. सो ये जब करेंगे आपको तो उसका ये आएगा. so उसमें ये इक्वेशन माइनस करेंगे तो आपका is equal to delta H rho G. delta H मतलब difference in the height, okay, and rho means density and G means acceleration due to gravity. So therefore pressure differential, that is delta P between two points, can be calculated by the distance between those points in the fluid. उनमें distance कितना है, उसमें height कितना है, so according to that it can be calculated. Pressure differential, okay, that can be calculated. So pressure difference, the delta P between any two points can be calculated by measuring the distance between those points of fluid, 2 points, ठीक है. Now इसका क्या ये, इसको बोलेंगे fluid static. So this fluid static, what is the application of fluid static? मैंने यहाँ पे भी लिखा था. So application of fluid static. So fluid static principle is used in the working manometer. So application क्या है fluid static का? So this principle is used in the manometer. And what is the manometer? Manometer is the device, manometer is the tool, manometer is the device, manometer is the tool which is used to measure the pressure differential. Pressure differential के लिए manometer use करते हैं. So to measure the pressure differential, manometers are used. इसके ऊपर क्वेश्चन आ चुका है GPAT 20 में. The device used to measure the pressure difference, also used to measure the flow of fluid in the Bernoulli's theorem. So this fluid static is also applied to measure the flow of fluid in Bernoulli's theorem. So ये application है उसका. You can see over here. So again I would like to explain you. So वहाँ पे जो 2 points दिखे थे अपने point 1 point 2, एक point पे ज़्यादा flow हो रहा था, एक point पे कम flow हो रहा था. Why? So you can see force acting on a point 1. Okay, force acting on point 1 is equal to force on the surface and force plus force exerted by liquid above the point 1. Okay, at the point 1 you cannot measure the force. At the point 1 forces are nullified. Okay, that's right. So above the point 1 you can only measure the pressure or force. Okay, pressure term बाद में आएगा, पहले force. So force on the surface plus force exerted by liquid above the point 1. Now substitute that force term by this. Okay, as force is nothing but the force क्या होता है is equal to pressure into area of cross sectional area. Okay, so just replace. So यहाँ force acting on a point 1 क्या होगा? Pressure at a point 1 into surface area. ये force क्या है? Pressure into surface area. Now is equal to force on the surface, मतलब यहाँ पे क्या आएगा? Pressure into surface area. Plus क्या है? Force exerted by liquid. So यहाँ पे plus mass into acceleration. Above है ना? Above the point 1. वहां पे मास इंटू एक्सेलरेशन, ये फ्लो टर्म आएगा. So pressure at point 1 into surface area, you can see P1 and S, surface area, S for surface, is equal to PS. Yes, PS मतलब क्या, pressure at a surface, pressure at a surface into surface area, plus mass क्या है, mass is equal to वॉल्यूम इंटू डेंसिटी. डेंसिटी क्या होता है कि लिक्विड है ना, डेंसिटी इज इक्वल टू मास अपन वॉल्यूम. तो मास इज इक्वल टू क्या होगा आपको, मास इज इक्वल टू क्या होगा, डेंसिटी इंटू वॉल्यूम. सो वॉल्यूम इंटू डेंसिटी, ये मास के लिए ऐड किया है. एक्सेलरेशन इज नथिंग बट द एक्सेलरेशन ड्यू टू ग्रेविटी डिनोटेड बाय g. देन अगेन ओके, सो सेम थिंग. सो वॉल्यूम इज इक्वल टू हाइट इंटू एरिया. वॉल्यूम का फॉर्मूला होता है हाइट इंटू एरिया. सो हाइट इंटू एरिया इंटू डेंसिटी इंटू एक्सेलरेशन ड्यू टू ग्रेविटी. तो इसको ये पूरा ऐसा आएगा, P1s इज इक्वल टू PS प्लस H1s रो g. रो क्या है, डेंसिटी, g क्या है, एक्सेलरेशन ड्यू टू ग्रेविटी. डेंसिटी इज रो एंड एक्सेलरेशन ड्यू टू ग्रेविटी. H क्या है, हाइट, H क्या है, ये हाइट, ये हाइट, और ये क्या है, एरिया. नाउ at this point 1, so this will be the pressure, this will be the pressure experienced by liquid at point 1. Now similarly you have to draw the equation for point 2. So point 2 के लिए ये equation आएगा, यहाँ P2s is equal to PS s plus H2 आएगा यहाँ पे, and s rho g, सेम थिंग. ठीक है, यहाँ पे देखो P2 into s, PS plus H2 rho g. Rho means density, g means acceleration to gravity. Now pressure difference, आपको difference कैलकुलेट करना है कि what is the difference in pressure which is felt at a point 1 and point 2. दोनों जो पॉइंट है, दोनों जो ओपनिंग है, उसमें प्रेशर डिफरेंशियल कितना है. फ्लो वहां पे एक जगह पे फास्ट फ्लो आएगा, एक जगह पे कम आएगा. क्यों, बिकॉज वो दोनों जगह पे प्रेशर डिफरेंशियल मतलब प्रेशर डिफरेंस एक्सपीरियंस किया जाता है. वो प्रेशर आपको निकलना है कि कैसे निकलेंगे वो. सो P1 minus P2, okay, you just do P1 minus P2 means you will get a pressure differential, that is delta P. Now ये दोनों इक्वेशन, ये इक्वेशन पहला इक्वेशन है ये, so 3 minus 5, so 5 minus 3, okay. So you will get a like this, delta P is equal to delta H rho g. Delta P is equal to delta H rho g means the pressure differential or different pressure experienced at different point, that is dependent on the height, then density of liquid and acceleration to gravity. So delta H depends on the delta P, that is pressure differential, depends on the delta H and rho g. Delta H means difference in the height, okay, and rho is density, g is nothing but the acceleration to gravity. So this is the fluid static. Now manometer क्या होता है, what is manometer? Manometer is the device which is used to measure the pressure difference. Question आ चुका है GPAT में. Manometer is a device used to measure the pressure difference. Now manometers are the devices used to measure the pressure difference. Okay, remember question आ चुका है. Now there are different types of manometer, like simple manometer class होती है उसका. Simple manometers are most commonly used. Remember, simple manometers are most commonly used, and it consists of a U-shaped glass tube. ऐसा U-shaped glass tube होगा उसमें, glass tube like this, yes. And it is filled with the different liquid, two different liquid. उसमें दो liquids होंगे. It is filled with the two different liquid which are immiscible, okay, and they are different in the density. उनका density different होगा. So if two mixtures of liquid having different density and they are immiscible, they are poured in this tube, what will happen? जिसका डेंसिटी ज्यादा है वो नीचे रहेगा, जिसका डेंसिटी कम है वो ऊपर रहेगा. So there exists a meniscus, there exists a boundary layer. Okay, now so if pressure is applied at one point, so both liquid will feel a different pressure. So simple manometers work on this principle. Okay, so we'll see it again in next lecture. That so manometers are classified. Simple manometers, they are most commonly used. It is simple manometers, you can see it is also called as U-tube manometer. So there is a U-shaped glass tube which is filled with the liquid having two different liquid having different density and they are immiscible. Okay. Okay. If high pressure difference, you have to measure a high pressure difference. बहुत ज़्यादा pressure difference में एक point में दूसरे point में आपको वो measure करना है तो you have to use mercury. Okay, in this one of the liquid you have to use mercury. जो दो liquid है ना YouTube में मतलब U shaped tube में जो दो liquid डालेंगे आप depends in the density and immiscible. So out of that one should be mercury if you want to measure high pressure difference. ये important question आ सकता है. So if high difference is to be measured, mercury is the one liquid. Mercury is the one liquid as a mono okay, as a manometric liquid. So mercury is used as a liquid in a manometric liquid. Manometer में उसको एक liquid होंगे. दूसरा दूसरा हो सकता है दूसरा. Pressure difference. If pressure difference is very small, so if you want to measure pressure difference which is very small, so then you can use alcohol, water, or carbon tetrachloride. They are also used manometric liquid. उसका application क्या है? So application of this manometer, measuring the consumption of gases in the chemical reaction. ठीक है, chemical reaction में क्लोरीन का गैस आपको react करना है किसी के साथ में. So how much chlorine gas is being reacted? So you can measure using the manometer. Because pressure difference will give you difference in the height and then lastly mass उससे density mass height उसे calculate कर सकते हो का mole कितना react हुआ है. So measuring the consumption of gases in the chemical reaction. Okay, this simple method along with the flow meter they are also used. Okay, along with the flow meters they are also used for the measurement of flow of fluid. For example, venturi meter is there, orifice meter is there for measuring the pressure head using manometer. And pitot tube is there. Pitot tube is also used to measure velocity of head using head. मतलब ये head जहाँ पे है वो उसका term होता है pressure. Head means pressure. So the term pressure is nothing but the head. Head क्यों बोलते हैं? So in the hydraulics they use the head term. Okay, pressure head because of the height होता है ना height की वजह से difference होता है ना pressure में. That's why the difference in the pressure at 2 point because of the height only. That's why in hydraulics they use pressure head term. Second type का manometer होता है differential manometer. So first manometer is simple manometer, most widely used. YouTube manometer is the example. And second is a differential manometer. So it is a very sensitive device and used to measure the small pressure differences. बहुत ही कम pressure difference है तो उसको use करते हैं. याद रखना. You have to remember this. They used to ask question. Okay. Simple manometer is used when one of the following condition. उसमें आएगा आपको when pressure difference is very high at 2 points. So when pressure difference is very small, at that time differential manometer is used. So it is a very sensitive device and used for measurement of small difference in pressure. It is also known as two fluid U2 manometer. Question आ चुका है. Two fluid U2 manometer. Okay. Then two इसमें क्या होता है? In this also there are two immiscible liquids. Those immiscible liquids have very less difference in the density. Very less difference in density. So two immiscible liquid having nearly same densities, or you can say very small difference in the densities. Okay. So differential manometer they are occasionally used. Simple manometers they are commonly used. Okay. They are sensitive device and useful for measuring even small gas pressure rate. इसका ये use है. Now third type होता है inclined manometer. Inclined manometer they are very limited. They have a very limited application. They are not discussed over here. इनका कुछ नहीं. तो आपको सिर्फ याद रखना है there are three type of manometer. Simple manometer, okay, differential manometer and inclined manometer. Simple manometers are mostly commonly used, and they, for example, YouTube manometer. So if you want to measure difference, if measure difference in the pressure is high, so at that time mercury is the one of the liquid. If pressure difference is small, then alcohol, water, or carbon tetrachloride is the one of the liquid. And differential manometer means they are very sensitive. They are used for the measuring a very small pressure difference. ठीक है. Fluid dynamics मतलब क्या है? So fluid in the motion. So manometer क्या होता है? Again, device used to measure the pressure difference. Three types of manometer are there: simple manometer, differential manometer, and inclined manometer. ये repeat ले रहा हूँ. There are three types: simple, differential, and inclined manometer. So device used to measure the pressure difference. So most commonly used a U-shaped glass tube filled with the two immiscible liquid A and B. इसमें दो immiscible liquid होगा A and B, having difference in the density. If you want to, if the measurement is of high difference, pressure differential बहुत ज़्यादा है, so in that case mercury is one of the liquid, and if pressure difference is very small, alcohol, water, and carbon tetrachloride can be. Then second type is application का measurement of consumption of gases in the chemical reaction. Along with the flow meter, it is used for measurement of flow of fluid. For example, benchrometer, orifice pattern tube. They measure the velocity head. They measure the pressure head using manometer. Differential manometer, occasionally they are used. They are not routinely used for the measurement of small pressure difference. They are sensitive and used for the measurement of small pressure difference of gas. तो उसका use है to measure the pressure heads. So differential manometer, they are mostly used for the measurement of pressure head, measurement of small pressure difference in the gas. They are also known as a two fluid U-tube manometer containing two immiscible liquid near about same density, or you can say there is very little difference in the density. Inclined manometer, they are having limited use and they are not discussed. You can say over here यहाँ पे क्या है, it is a simple manometer. First जो है construction of simple manometer. So this is known as a fluid A. Okay, this is known as fluid B. So a glass tube, U-shaped glass tube होता है, उसमें दो liquid डाला, liquid difference in the density होता है उनमें, they are immiscible. So that's why one liquid will be at this way, one liquid will be like this white, and those liquid which is having high density, they will be at the bottom. Okay. Now if you apply a pressure at this arm and this arm, so let, for example, pressure 1 is applied to this arm, okay, and pressure 2 is applied to this arm. If there is a difference in pressure, okay, if there is difference in pressure, this height will be different. Height of this liquid will be different, and that is used, that height delta H, difference in the height, that will give you difference in the pressure. Okay. So derivation is same like as that of the we are seeing जो पहले देखा है उसके जैसे derivation. Then this is known as a differential manometer. Differential, उसका use क्या है, to measure the pressure difference which is very small pressure difference के लिए. So they are used to measure the pressure rates in the gases. याद रखना है. और fluid dynamics, so इसमें आपको आता है Reynolds experiment. Right? Reynolds experiment. इसने क्या किया था? So he studied the behavior of liquid. Okay. So construction for this Reynolds experiment. So you will have one glass steel containing water. A glass steel containing water. So it is connected with the valve to control the flow of fluid. Flow of that water. Okay. Flow of fluid of water. So water tank, glass water tank having water connected with the valve to control the flow of water. Another tank is there which is having colored solution. Now this colored solution can be introduced at this point through a nozzle, and the flow of water will be controlled through valve. When there is a low velocity of this water, यहाँ पे जब water slowly जाएगा, low velocity of water. So when there is low velocity of water, this colored solution is introduced in this column at any point in the form of fine thread, in the form of fine layer. Okay? Now if you say अगर if this water, the flow of water or the velocity of water is less, then what will happen? So this colored solution will enter into the this column in the form of a streamline or a thread. धागे जैसा ये अंदर आएगा. It is clearly visible. So there will be a simple colored stream or a simple colored thread. Okay, when the flow of water is less, Now if you increase the flow of water over here, यहाँ से अगर ज़्यादा water का flow किया, so what will happen? If you increase the flow of water, so what will happen? So this colored solution stream, will get mixed up, because of the Eddy's diffusion. Okay, Eddy's diffusion, and whole solution will be colored. Okay, this one is known as a turbulent flow. This one is known as a streamline flow. Streamline flow, or it is also known as a viscous flow, or it is also known as a laminar flow. This one is known as a turbulent flow. Turbulent flow, or it is known as a diffused flow. Turbulent flow or diffused flow. So I will explain this again in the upcoming slide. Okay, fluid dynamics deals with the study of fluid in the motion. Fluid dynamic मतलब क्या? Study of fluid in the motion. ये चैप्टर जो है इसके ऊपर 2 क्वेश्चन आता है मैक्सिमम. कभी कभी आता है, कभी कभी नहीं भी आता है. आएगा ये गारंटी नहीं. ओके, बट पढ़ना है आपको, मालूम होना चाहिए. Right? So fluid dynamics deals with the study of fluid, or fluid dynamics study deals with the study of liquid in the motion. Flow properties. Okay, flow properties of liquid is important. Flow properties of liquid is important in the study. Okay, to the study this simple liquids like gel, simple liquids in gel, ointment, creams, paste, etc., etc. So you need to understand the flow of fluid. The flow properties of fluid or flow properties of liquid is very important to study, because in case of simple lipids it is important. Gels, ointment, creams, paste, change in the behavior of liquid during the manufacturing and or handling of drugs, because there is a change in the behavior of liquid during the manufacturing or in the handling of drugs. So Reynold performed one experiment. Reynold. So it is the experiment. The experiment is to know the nature of fluid flow. Nature कैसा है, कैसा fluid flow होता है. Okay. For that purpose, Reynold conducted one experiment known as the Reynolds experiment. क्वेश्चन आपको आता है कि रेनॉल्ड्स एक्सपेरिमेंट इज रिलेटेड विद फॉलोइंग. ऑप्शन में आएगा ये साइज रिडक्शन, साइज सेपरेशन, ड्राइंग, फ्लो ऑफ फ्लूइड, ट्रांसपोर्टेशन ऑफ फ्लूइड. आपको मालूम है रेनॉल्ड्स नंबर इज रिलेटेड विद द फ्लो ऑफ फ्लूइड. So Reynolds experiment to know the nature of flow of fluid. Flow of liquid in a pipeline can be considered as a viscous or turbulent. So suppose that आपके पास में एक पाइप है, अगर पाइपलाइन है आपके पास में क्लोज, if there is a closed pipeline with you, ठीक है, and liquid is flowing through that pipeline, say pipeline or column. So there might be either, there are two types of flow. There might be either viscous flow or there might be either turbulent flow. Reynolds observed certain conclusion through above experiment. जो आपका पहले जो डायग्राम दिखाया मैंने, so by doing that experiment Reynolds observed certain conclusion. So conclusions of Reynolds experiment. So first conclusion क्या है? If the velocity of water is low, जो ऊपर से जो vessel था उसमें का velocity water. So if velocity of water is low, colored solution appears as a thread or fine stream, and okay, fine stream which is seen in the parallel lines. The flow is known as a viscous flow, or it is also known as a streamline flow, or also known as a laminar flow. So fluid particles is the fluid particles most in the layer, they are most in the layer parallelly. Okay, so most of the particles they are in a parallel layer. The fluid particle most they are in a layer or laminar, or they are sliding on each other, and heat transfer by lateral momentum, is not observed. क्योंकि स्ट्रीमलाइन फ्लो है तो lateral movement नहीं हो रहा है, साइडवाइज मूवमेंट नहीं हो रहा है, बिकॉज ऑफ दैट साइडवाइज मूवमेंट नहीं है इसलिए हीट लॉस नहीं होगा. Heat transfer by lateral movement is not observed. So during the laminar flow or during the streamline flow, heat losses are not there. So in case of turbulent flow, heat loss will be there. Right? That's why we have to, suppose you are transporting a steam for a evaporator. So if you lose the heat, so what is the use? So your budget will increase. आपको loss होगा. So that's why while designing a pharmaceutical company, you have to take all these things in consideration. But आजकल सभी लोग कंपनी वाले सब रेडीमेड देते हैं ना. So if velocity of water is less, so at that time colored solution will appear as a thread or streamline in the water. Okay, and at that condition, because the colored solution will slide on a layer and it will move parallelly. It is known as viscous flow or streamline flow or laminar. तीनों याद रखो नाम. Okay, laminar flow or viscous flow or streamline flow. So fluid particles must them, okay, most of the fluid particles in a they slides in a layer or in a lamina and they slides on each other. Heat transfer is a minimum because of the minimum lateral movement. Second condition, second observation, when the flow of that water is increased, when the increased velocity of water is there is a flow rate. It can be adjusted by your valve उसके लिए दिया है. So if you increase the flow rate, so what will happen? The thread of colored solution, this disappears. जो thread है वो color solution का एक line दिख रहा था वो आपको वो disappear होगा and enter the solution. Okay, entire solution gets colored. यहाँ पे entire. So at the higher velocity of water, the thread of the stream or thread of colored solution disappears and entire solution of that water get colored uniformly, indicating that there is a mixing, and this type of flow is turbulent. Mixing is due to increased eddies current. एडी मतलब साइज वाइज करंट जो है ना वहाँ पे वो इंक्रीज होता है. ड्यू टू इंक्रीज्ड एडीज करंट there is a mixing. Okay, when velocity velocity exceeds certain level, when velocity of water exceeds certain level, the flow no longer remains steady. तो जो है ना वो steady नहीं रहता, straight नहीं रहता, and there is eddies diffusion current appears which leads to mixing, and there is a continuous transfer of momentum to a adjacent layer, and this flow is known as turbulent flow and also known as a diffused flow. Okay, now third, change over from the flow from viscous to turbulent. Change over कैसे होता है? Change over the flow from viscous to turbulent. Streamline flow से turbulent कैसे होता है? So it is a very critical factor, and critical velocity is the velocity of, okay, critical velocity is the velocity. It is the average velocity of any liquid at which viscous flow changes to turbulent flow. Question आ सकता है, what do you mean by critical velocity? So critical velocity is nothing but the average velocity of any liquid at which the viscous flow changes to turbulent flow. Okay, so ये Reynolds का experiment है, Reynold का experiment है. This is construction. So first vessel is nothing but the vessel containing water, clean water हो गया, glass vessel containing water. So to control the flow, there is a valve. Okay, and this is a column. This one is a column. पहले clear करता हूँ. Okay, so this one is a vessel containing water, and this is a valve to control the flow, and this one is known as a column or simply pipe, column or pipe. Another tank is there containing color liquid which is introduced into this tank via nozzle. Now when the flow of water or velocity of water is less, at that time this colored solution enters in this and appears as a thread, appears as a simple thread, and there is no sign of mixing. यहाँ पे कोई mixing का sign नहीं, there is no sign of mixing because of the low flow. At that flow there is no eddies diffusion. Okay, and your color solution will appear as a colored jet or a simple thread. Okay, and this type of flow is known as a streamline flow. It is known as a streamline flow, also known as a viscous flow, also known as a laminar flow. Streamline, viscous or laminar flow. But if you increase the velocity of that water का increase किया velocity, flow rate increase किया, what will happen? So this thread, okay, because of the increased velocity, and that increased velocity leads to increased eddy diffusion and leads to mixing. Because of that, entire solution will be colored. This is known as a turbulent flow, or this flow is also known as a diffuse flow. Are you getting or not? Are you getting? Okay. Now Reynolds number क्या होता है? Reynolds number is equal to this. Reynolds number का formula है देखो. Reynolds number is equal to, okay, D then micro then rho divided by nu. So what is D? D is nothing but the diameter of pipe. Micro is nothing but the velocity, average velocity. Rho is nothing but the density of liquid in kilogram per meter cube, and nu, okay, and nu is nothing but the viscosity, okay, viscosity in the Pascal. Reynolds number, it is a dimensionless number. इसका कोई डायमेंशन नहीं होता बिकॉज यूनिट का जो भी विस्कोसिटी है, जो भी डेंसिटी है, जो भी डायमीटर का यूनिट है, वो सब कैंसिल होते हैं जब आप कैलकुलेट करते हो उसको. सो रिमेंबर रेनॉल्ड्स नंबर का फॉर्मूला याद रखो. रेनॉल्ड्स नंबर आर ई इज इक्वल टू, ये फॉर्मूले का क्वेश्चन आता है कि जैसे आपको बोलेंगे मैच द फॉलोइंग इक्वेशन विद देयर रिस्पेक्टिव लॉ. आपको एक में देंगे एक इक्वेशन, कॉलम में देंगे एक टाइप की इक्वेशन, दूसरे कॉलम में देंगे उसके नाम, रेनॉल्ड्स नंबर, किक्स थ्योरी, बॉन्ड्स थ्योरी, या फिर किरचॉफ्स लॉ, ओके, या फिर आपको देंगे ऐसा कुछ और, एक और भी लॉ होते हैं ना, तो वैसा लॉ देंगे. ओके, सो यू हैव टू रिमेंबर inertial forces are because of the mass and velocity of particle trying to diffuse into the fluid particle. ये क्या होता है inertial forces? Reynolds number is also known as a inertial forces divided by viscous forces. In the another way, Reynolds number is equal to inertial forces divided by viscous forces. Okay, Reynolds number is equal to d micro rho divided by nu. तो ये तो है, लेकिन उसको और भी टर्म है, आप ऐसे भी बोल सकते हो उसको. Reynolds number indicate the inertial forces and viscous forces ratio. The ratio of inertial forces and viscous forces. So inertial forces are because of the mass and velocity of particle trying to diffuse into the fluid particles. Viscous, okay, viscous due to viscosity. Okay, the viscous forces are due to the viscosity of the fluid, okay, which make the motion in a parallel layer. When the fluid at low velocity, when the fluid is at low velocity, inertial forces are less as compared to the frictional forces. Frictional forces is because of the viscosity, and the flow will be laminar or known as a viscous. So when, remember, inertial forces, they are because of the mass and velocity of the particles of the fluid, and viscous forces are due to the viscosity of fluid. याद रखो. Now when inertial forces will be more and will be more than viscous forces, at that time, sorry, when viscous forces will be more than inertial forces, at that time laminar flow is there. And when inertial forces are more than viscous forces, at that time turbulent flow is there. Okay, so यहाँ पे वही बोल रहा है. I will explain you again. So inertial forces are because of the mass and velocity of particle which are trying to diffuse into the fluid particle. Now viscous forces are due to the viscosity of fluid, okay, which makes a motion in the parallel layer. Viscous forces क्या है? They are responsible for the motion of fluid in the parallel layer, okay, and inertial forces, they try to mix up the particle with another particle, ठीक है, another fluid. तो inertial forces ज़्यादा होगा तो आपका टर्बुलेंट फ्लो हो जाएगा. विस्कस फोर्सेस अगर ज़्यादा रहेगा तो आपका स्ट्रीमलाइन और विस्कस फोर्स रहेगा, विस्कस फ्लो रहेगा. ओके, सो व्हेन फ्लूइड एट अ लो वेलोसिटी, व्हेन फ्लूइड इज एट अ लो वेलोसिटी, इनर्शियल फोर्सेस आर लेस. ये क्या है? लेस होता है एज कंपेयर टू फ्रिक्शनल फोर्सेस. मतलब क्या? फ्रिक्शनल फोर्सेस ज़्यादा होते हैं. सो फ्रिक्शनल फोर्स मतलब क्या है? इट इज अ फोर्स ऑफ विस्कोसिटी. सो फ्रिक्शनल फोर्सेस आर मोर, इनर्शियल फोर्सेस आर लेस. सो again your fluid will have a streamline flow, laminar flow or viscous flow. Okay, now if inertial forces are more than the viscous forces, so inertial forces are more than the viscous forces, so mixing will take place and the flow is turbulent flow हो जाएगा. Now if Reynolds number of a fluid is less than 2000, Reynolds number अगर fluid का less than 2000 है, so at that time there is a laminar flow. क्वेश्चन आता है इसके ऊपर, इंपॉर्टेंट है, ज़्यादा इंपॉर्टेंट है ये, 2 बार लूंगा मैं. So if Reynolds number is less than 2000, laminar type of flow is there. If Reynolds number is more than 4000, turbulent type of flow is there. And if Reynolds number is between 2000 to 4000, That means the flow is changing from laminar to turbulent. क्वेश्चन इसके ऊपर आता है, ऑलरेडी बहुत बार क्वेश्चन आ चुके हैं इसमें। इस चैप्टर में 2-3 जगह पे ही क्वेश्चन पूछने लायक है। कौन सा? एक तो ये है रेनॉल्ड्स नंबर इतना है तो क्या होगा, रेनॉल्ड्स नंबर उतना है तो क्या होगा, एप्लीकेशन क्या है रेनॉल्ड्स नंबर का, या फिर डिफरेंट मैनोमीटर्स, ठीक है, यूट्यूब मैनोमीटर या फिर डिफरेंशियल मैनोमीटर, उसके ऊपर एक क्वेश्चन आते हैं यहाँ पे, ठीक है। तो याद रखो, इफ Reynolds number is less than 2000, type of flow is a laminar flow. If Reynolds number is more than 4000, type of flow is the turbulent flow. And if Reynolds number is between 2000 to 4000, so flow changing from laminar to turbulent. So what is the application of this Reynolds number? It is used to predict the flow of fluid, ठीक है, flow of fluid, to study the physical stability. यहाँ पे देखो physical stability है, to study the physical stability of suspension emulsion, rate of settling of particle in the suspension, or rate of settling of globules in the emulsion. That depends on the movement. That depends on the movement. If it is a laminar movement or turbulent movement, well, that depends on the movement. So Stokes law is applicable for that. Rate of settling of particles in the suspension, rate of settling of globules in the emulsion. So it will be modified because rate of settling depends on the type of flow. Flow कौन सा है? So it is modified, and it is modified with inclusion of Reynolds number. तो स्टोक्स लॉ में रेनॉल्ड्स नंबर को घुसा दिया, और उसके ऊपर भी एक अलग थी. So if Reynolds number is less than 0.5, what type of flow is there? If Reynolds number is less than more than 0.5, it is turbulent. If Reynolds number is less than 0.2, it is a laminar flow, like that. So if it is modified into include Reynolds number, Stokes law is applicable when Reynolds number is less than 1.3. Sorry. Stokes law is applicable when Reynolds number is less than 1. Reynolds number is also applicable to study the rate of heat transfer, okay, which in turn depends on the type of flow, laminar flow or viscous flow, or also known as a streamline flow. When fluid, okay, flow in which fluid particles moves in a layer or lamina or in a layers by sliding with one another, that is known as a laminar flow or viscous flow. Turbulent flow किसको बोलते हैं? When at a certain velocity the flow will no longer remain steady and there is a eddy diffusion. Eddy's current will affect the fluid particles are distributed and get mixed up with each other. Two fluids particle, okay, दो fluid है ना और दो liquid, so that's why there is a continuous transfer of momentum to the adjacent layer. Such diffused flow is known as a turbulent flow. So variation in the velocity of flow across the cross section of pipe. When local velocity of fluid plotted against the distance from the wall, some conclusion can be drawn. मतलब वेरिएशन इन द फ्लो अक्रॉस द क्रॉस सेक्शन पाइप, मतलब देखो जो पाइप है उसका सेंटर होता है, उसका एज होता है ना, सेंटर पे फ्लो कितना होगा, एज के ऊपर फ्लो कितना होगा, ठीक है. सो वेरिएशन विल बी इन द वेलोसिटी ऑफ फ्लूइड व्हेन लिक्विड इज फ्लोइंग थ्रू अ पाइप. सो देयर विल बी वेरिएशन, देयर विल बी डिफरेंस इन द फ्लो, ठीक है. सेंटर में बहुत ज़्यादा फ्लो होगा, जो आपका सरफेस होगा इनर सरफेस ऑफ पाइप वहाँ पे कम फ्लो होगा, ठीक है. सो वेरिएशन इन द फ्लो across the cross section of pipe. Well, when you plot a local velocity of fluid against the distance from wall, some conclusion can be drawn. Okay, some conclusion can be drawn. So flow in the middle of pipe is faster than the flow near to the wall. जो पाइप है उसके सेंटर में जो फ्लो होता है वो ज़्यादा होता है. So flow in the middle of pipe is faster than flow which is near to the pipe. Second conclusion है velocity of fluid. Velocity of fluid reaches to zero as pipe wall is approached. पाइप का जो सरफेस है वो अगर रीच हो गया वहाँ पे तो वेलोसिटी जीरो हो जाता है, ठीक है, नियर अबाउट. एंड द एक्चुअल सरफेस ऑफ पाइप वॉल वेलोसिटी इज जीरो. ओके, एट द एक्चुअल सरफेस ऑफ पाइप वॉल वेलोसिटी ऑफ फ्लूइड इज जीरो. मतलब जैसे जैसे वॉल नजदीक आएगा पाइप का सरफेस नजदीक आएगा वेलोसिटी कम होते जाएगा. ओके, और एट द वॉल मतलब एग्जैक्टली वॉल के यहाँ पे वेलोसिटी कितना रहेगा, जीरो रहेगा. इन द विस्कस कंडीशन एवरेज वेलोसिटी होल क्रॉस सेक्शन इज 0.5 times. इन द विस्कस कंडीशन मतलब इन द स्ट्रीमलाइन फ्लो, और इन द लैमिनार फ्लो the average velocity over the whole cross section of pipe is 0.5 times more. Now, in case of turbulent flow, the average velocity over the whole cross section pipe is 0.8 times more. तो turbulent flow में क्या है, velocity ज़्यादा होता है, इसलिए mixing हो जाता है. So in the turbulent flow, velocity is more and there is a mixing of liquid. That's why. Now critical velocity, I have told you the average velocity of any fluid at which viscous flow changes into turbulent flow. It's a critical velocity. Change over of flow from viscous to turbulent is nothing but the critical factor. So Reynolds number क्या है? Reynolds number is equal to d u rho divided by rho क्या है? Density and u क्या है? Viscosity. ये क्या है? Acceleration due to gravity. ये क्या है? Diameter of pipe. Okay. So Reynolds number is inertial forces divided by viscous forces. Reynolds numbers are also known as Reynolds number is also known as inertial forces divided by viscous forces. Okay. That is equal to mass into acceleration of liquid flowing divided by shear rate shear stress into area. Viscous force क्या है? Shear stress into area and inertial force क्या है? Mass into acceleration of liquid. So inertial forces ज़्यादा हो गए, viscous forces कम हो गए, तो फ्लो बनेगा टर्बुलेंट. इनर्शियल फोर्सेस कम हो गए, विस्कस फोर्सेस ज़्यादा हो गए, तो फ्लो बनेगा लैमिनर. Now again you have to remember this. If Reynolds number of a fluid is less than 2000, laminar type of flow is there. If Reynolds number is more than 4000, turbulent type of flow is there. If Reynolds number of fluid is between 2000 to 4000, so flow is changing from laminar to turbulent. Question is over. आ चुके हैं. You have to remember this. Okay, from this chapter. Applications of Reynolds number. So it is used to predict the nature of flow. Then we have seen the physical stability of suspension emulsion. So that Stokes law is applicable for that, and it can be modified according to the Reynolds law. For the rate of heat transfer, we are next. We will see Bernoulli's theorem. I will save the recording once.